Okay, we're just going to extend what we had talked about in 2.3 here in 2.4. We're going to just talk about slope a little bit more. So we've gone over how to find slope with 2 points, how to read equations of lines to find slope, and all of that stuff. Now we're just going to go a little bit further and still talk about equations of lines, but creating equations of lines when they do something specific, like they're parallel or they're perpendicular to another line. And that involves being able to read the slope of the lines and knowing how to change it if you need to change it. So if two lines are parallel, they have the same slope. That's what this first thing is saying. So when you have parallel lines, the slopes should match. You don't have to change them at all. You don't have to do anything to those numbers. They should just stay as is. Now, if you have, they're calling it two distinct non-vertical lines. And if they have the same slope, then that's just telling you that they're going to be parallel to each other. If you have two distinct vertical lines and they're both undefined, those would also still be considered parallel. So kind of just the key idea there is if you notice that two lines, no matter what their equations look like, and you have the same slope, that means that they're parallel. So we're going to do an example here where we want to write an equation of a line that passes through the point negative 2, 5, and it's parallel to the equation y equals 3x plus 1. The only thing I need from that equation that they're giving me, the y equals 3x plus 1, is what the slope is. Where's the slope at in this equation?
It'd be 3 over 1.
It'd be 3 over 1. I'm just going to think of it as the 3. Okay, but that's what I need right now. And then I'm going to take this slope and this point over here, the negative 2, 5, and I'm going to write a new equation. We're going to start out in point slope form, which remember is y minus y1 equals m times x minus x1. What are we going to put in for the y1? The 5, because that just comes from your coordinate. And then in for slope, since we know that they're parallel, we're going to use that 3 from over here. We're not going to change it. And then it would be in the parentheses x, and then what? It'd be minus negative 2, which becomes plus 2. So I'm going to go ahead and just skip that double negatives and just write it as a plus sign. Okay, and then what would you guys do here if I wanted to rewrite this in slope-intercept form? Distribute first. And then add 5 to what? The 6, only the 6. So then it would say y equals 3x plus 11. That would be a parallel line to the one that they gave us. Because again, if I just do a really quick check, both of my slopes are 3, that tells me that they're parallel. They would just have different y-intercepts. Okay, so let's take a look at the next one here. Asking something similar, they want a new equation that passes through that point 6, negative 1, and it's parallel to y plus 3 equals 7 times x minus 1. What form are they giving you this equation in? Not slope-intercept. Slope-intercept is y equals mx plus b.
Where's the point slope?
This is the point slope form. Where's the slope sitting at in that equation?
Be 7 would be slope.
The 7, because it's in front of the parentheses. Okay, so now we handle this the same way that we did the last one. So let's go ahead and plug in our information. So it would say y, what? Minus negative 1, which becomes positive 1. Equals what? And then, is it plus 6?
X minus 6.
Minus 6. The only time it changes to a plus is if the number you're plugging in is negative. So if it's already positive, it's going to stay as a minus sign. Okay, and then I'll let you guys go ahead and simplify that. And when you have it, I want to know what you got. Good. Okay. Questions about parallel lines? All right, so now let's talk about perpendicular lines. You guys know what perpendicular means? You guys remember? What do they do when they're perpendicular? Those would be parallel.
Maybe like this.
What happens there? When they cross like that, what happens?
They intersect.
They intersect. Something really special happens there, though.
Don't they just have like negative or like opposite things and things?
Okay, you're getting real technical. I even want to go but back before that. Like I want you to think about like geometry a little bit here.
Oh God. What do I really think about
I don't remember that.
What happens here?
Right angle.
A right angle. Okay. When you have perpendicular lines, there's going to be a 90-degree angle in there, which is why they do what David was saying with their slopes. They have what we call opposite reciprocals. Opposite means they change the sign, and reciprocal is when you flip the number as a fraction upside down. Okay. If you were to multiply those two numbers together, their product would be -1. So that would be another way to determine, like if you were just looking at lines and you wanted to know if they were perpendicular, take a look at those two slopes. If you multiply them and you get a -1, that's telling you then that they would be doing this. So when we have perpendicular lines and we want to write an equation, we're going to have to do a little bit more work here. Okay, but I want you to always be thinking about opposite reciprocal. Okay, and like I said, opposite just means they're going to change signs. So if it was positive, it'll switch to negative. If it's negative, it's going to switch to positive. And then reciprocal is looking at the fraction. So looking at slope as a fraction and then flipping it upside down. Okay, so let's take a look at this example. We've got a point 2, 3, and we've got this equation y equals 4/3 x plus 11. What is the current slope of that line? 4/3. Now, this isn't parallel anymore, so I can't just keep 4/3. I have to change it. What would be the opposite reciprocal of 4/3?
3/4.
And negative. Okay, so that's what we want to use for our new slope, -3/4. Make sure you do both of those things in order to make it truly perpendicular. So I'm going to start out the same way we were doing before. Y minus what? 3 equals my new slope here, which we said was -3/4 times x minus 2. Okay, if we start out by distributing, we are dealing with a fraction here. It's probably not going to be the nicest numbers, but if you need to, you can just type in your fractions on your calculators and keep them as fractions. Because this would say y minus 3 equals -3/4 x. And then if I take this -3/4 times a -2, it becomes positive. And there can be a little bit of simplification there. Like you can take the 2 and go into the 4. So it really becomes 3/2 as a fraction. Or you might have had your calculator say like 1.5. Okay, and then what would we need to do? Last thing.
Wait, drag your totally don't remember.
We got to add 3 over, right?
Yeah.
So y equals -3. Oh, I forgot my x. Is that what you were trying to tell me?
Yeah, that just happened.
And then 3/2 plus 3. 9/2. I would just use your calculator to help you with those fractions, especially when you have to multiply and add whole numbers and all that stuff. Okay. Any questions right now? You good?
Yeah.
Okay. All right, if we turn the page over here, slope is also known as rate of change. Rate of change is just another way of kind of describing like that rise over run that we talked about in the last section. Because rate, it would be like how fast it's going, and change is just describing how it's moving. Like, is it going up? Is it down? Is it left, right? Like those kind of movements. So when we read problems and they say rate of change versus slope, it means the same thing. They're wanting you to figure out what's this connection between our x and y coordinates here. So in this first example, it says in 1990, 9 million adult men in the United States lived alone. And then in 2008, 14.7 million adult men lived alone. We want to use this information to find the slope, or they could call it rate of change, of the linear function. They want us to express the slope as 2 decimal places and then describe what that means. Okay. So when we look at these numbers up here, 1990 and 9 million, 2008 and 14.7 million, we have to first figure out what's my X and what's my Y. When you're looking at a problem like this, X is always known as the independent variable. It does not matter what the Y is doing. X is never impacted by that. So a lot of times, anytime they talk about time, that's when your X variable is going to be present. So like years, we can't control years. We can't control the time. Like no matter what, time is ticking constantly throughout our life. So like we can't control what's happening year to year as far as time goes. But there would be other factors that were maybe influencing why these men were starting to live alone. So that can be more changed based on where you're at, maybe climate of the city you're living in, where you're at career-wise. Like those things are a little bit more variable, but time is not. So I'm going to think about these as two coordinates, like 1990, and I'm just going to write 9. I'm going to know, though, that I'm talking about 9 million. I'm just not going to write out 9 million because that'd be a lot of zeros that I just don't really want to deal with right now. And then the other coordinate would be 2008 and 14.7. Okay, so what would we plug in for slope? What goes on top?
It's 9 minus 14.
Yeah, 9 minus 14.7 or 14.7 minus 9. It doesn't really matter the direction we subtract. And then the bottom would do the same thing. 1990 minus 2008. Or vice versa if you're flipping those around. So what would be 9 minus 14.7?
Negative 5.7. I don't know, I just did that in my head.
Someone confirm or deny? Is that what you got? Who's got a calculator? I do. 5.7?
Yeah.
Yeah. Okay. How about 1990 minus 2008? How many years have passed there?
18.
Okay, so negative 18. If we divide, we're going to get to a positive slope here. And what is it? They want 2 decimal places. Point 332, if we round it maybe. Okay, so let's talk about what this means. Okay, we're not talking about like 0.32 people here. Because remember, I cut my numbers down. I didn't write out 9 million. This is talking about millions of people. So 0.32 million. So not even like a full million people. We're talking about like a fraction. So 0.32 million more men are doing what?
Living alone.
Are living alone per year. So this would be similar to that problem that we had the other day with, trying to look back at what that was talking about. It was something like the global temperature and like atmospheric carbon dioxide concentration. We had to like do the whole thing. Like we had to find slope and then we had to write an equation of a line. This is asking you to just find slope and then interpret what that means. So we could eventually then go and make an equation of a line and then predict, like in this year, 2025, about how many million men would be living alone now if that rate of change was consistently continuing to happen over time. All right, last thing we need to talk about here. So kind of on the rate of change topic, we're still talking about trying to find that. They want us to now find the average rate of change for a function. Now the function they're giving me there is x to the third from -2 to 0. And so to find average rate of change, average would mean like if you did rate of change a bunch of times, you added them all up and divided by however many times you did that. That's what they're kind of asking you to do here. If you look at how this is set up, like where they're getting this piece from, they're evaluating the function at these two numbers, -2 and 0. So they put -2 in for the x, and that's where they got this -8 from. And then when they put 0 into the x to the third, that's where they got the 0 from. So these two pieces here in the equation are just showing you, like the top is showing you what happens when you are evaluating x to the third at those two numbers, -2 to 0, because that's like my parameters on my range. Then on the bottom, you just subtract those numbers. So they took -2 minus 0. That's how they got -2 on the bottom. And so then you're just down to a 4 when you divide. So we're going to do one here together. We want to find the average rate of change for this function, x squared plus 3, from 1 to 4. So let's first start out by evaluating the functions at 1 and at 4. So when you're evaluating a function, remember that just means you're putting it in for x. So I'm going to do 1 squared plus 3 and 4 squared plus 3. What would those come out to be?
19 and 4.
Good. So now we're going to just take these numbers, and the 19 and 4 are going to go on the top, and you're going to subtract 19 minus 4. And then we're going to do the same thing on the bottom, but with the numbers that we were evaluating at. So like 4 and 1. And they need to stick together. Like when you put 4 in, you got 19. So notice how I wrote those both first. And when I put 1 in, I got 4. So that's why I put those first. What's 19 minus 4?
15.
And then that'd be over 3. So this simplifies to just 5.
Boom.
There you go. That's it.
You should get like a sound